I've drawn a pretty intricate function here, kind of a crazy function. And so on the very left, it's asymptotic on the left side in the horizontal. In other words, it approaches this horizontal line, and then as it comes close to here, it approaches the vertical line asymptotically. Never quite touches the vertical line or the horizontal line on this side. In between, it just goes up and it comes down, and it gets closer and closer to the asymptote line. And then on the right side, this is sort of a mirror image on the left side. Very similar thing. So crazy looking function. If I was really motivated, I could actually come up with that function, and I'm quite certain it's going to be a rational function. In other words, it's going to be a polynomial divided by a polynomial. And probably most likely the denominator is going to be a quadratic, because it'll have two places where it equals to 0, which gives you those asymptotes. So anyway, let's not worry about that though. It's a bit beyond the scope of this course to try to figure out what function this is. But it is kind of interesting, I think. Now the domain is almost everything. All right. What's excluded out of the domain are these two asymptotes, vertical asymptotes, -1 and +4. So we cannot plug those numbers into our function. And in other words, those are not valid inputs. If I put -1 or 4 into the function, I might get something like division by 0, which is impossible. And that's why the graph doesn't exist there. We can't graph there. So our domain is going to be all the x's, actually all the real numbers, because the graph occupies everything from left to right, with the exception of these 2 points. So let's do it this way. The domain would be all the x's in this left-hand interval from -infinity to -1, -infinity to -1, parentheses, or, don't forget the word or, it stretches between -1 and 4, so from -1 to 4, or from 4 to infinity. So there are 3 intervals there, this part, that part, and that part, and they're connected with the or, logical conjunction. That's important in our interval notation. And there it is. That describes the domain. Now, and I use parentheses because they don't touch those points, -1 or 4. So domain is a bit complicated. The range I don't think is nearly as complicated at all. And because this entire function, where are the y values? The y values at most go up to -1, and everything, the whole function is graphed below there. And in fact, all the y values are taken up. So you might say the range of this function goes from -1 down to -infinity. So turn that into interval notation. The range would be the set of y's going from -infinity up to -1. And I put a bracket there because it does come up and top out at -1. It does equal -1 there. So there's a range, and that's more complicated than I'm ever likely to give you, but I thought it would make a good example to discuss. So anyway, so we talked about domain and range of functions, and at this point it's far easier to describe domain and range if you have the graph in front of you. It is possible, I think, with some difficulty at times, to figure out domain and range from just the algebra itself, and you know, you should be able to recognize it from the graph. And so now earlier I talked about something on your calculator that has to be defined as a function. Recall that the inverse sine function, key sign with a -1 on it, is defined as a function by restricting the range to a certain interval, by taking this mathematical relationship and cutting it off to this range only. That's how they create a function. So there's an application of range that was quite productive in terms of making calculators. So, all right, well, let's time to move on.